Good day everyone. Today we're going to solve a problem in Chapter 3, Total Hydrostatic Force on Surfaces from the book Fundamentals of Fluid Mechanics, 6th edition by Monsoon. Here's the problem. A 4-meter long curved gate is located in the side of a reservoir containing water as shown in the figure. Determine the magnitude of the horizontal and vertical components of the force of the water on the gate. Will this force pass through point A? Explain. First, let's put down all the given values. Radius 3 meter, width 4 meter. The gate is shaped like a quadrant of a circle, hence the height of the gate is equal to its radius. The depth of the gate, HC, is 6. The height of a reservoir, which is 6 meter, and the radius, which is 3 meter, divided by 2 equals 7.5 meter. So now, let's make our free body diagram. The force of the water on the gate is the same as the force of the gate on the water, but in the opposite direction. The horizontal force acting on the gate is given by, for equilibrium, summation f of x is equals to 0, or horizontal force is equals to F2 equals to specific weight times HC times area. Substitute all values, the specific weight of water times HC 7.5 and the area, radius times width, we get 882.9 kilonewtons. And the vertical force on the gate is given by summation of Fy is equals to 0, or vertical force is equals to F1 plus weight, where F of 1 is equals to specific weight times volume of a reservoir, and the weight is equals to specific weight times volume of the gate. Substitute the values and we get the vertical force 983.69 kilonewtons. The direction of all differential forces acting on the curved surface is perpendicular to surface, and therefore the resultant must pass through the intersection of all these forces, which is at point A. So the answer is yes. This is for today's problems. We hope you learned something from us and kindly see our next videos for more information. Thank you.